Everyone, welcome to our presentation today. Today we're gonna present about factors affect the price of apartment among Hanoi. Our group member contain Nguyễn Hà My, Lê Hoàng Yến, Vũ Minh Giang, and the last one is me, Nguyễn Anh Tuấn. We decided to divide our presentation into 5 parts. The first one is introduction. The second one is literature reviews. The third one is methodology. The fourth one is data analysis. And the last one is conclusion. Now we're going to move on. The first part is introduction, which is in charge by me. So I'm going to give you some basic information about the present situation. As you know, the population in Hanoi City has been increasing rapidly in recent years. So people need for a living place, and however, to have the landed house in Hanoi is very hard. So it makes people concentrate more on owning or buying the apartment. So now here's some state expectation and economic implication. We expect that the square increase will make the price of a flat increase. And however, the location and the density has a negative effect on the price. Like when the location decrease and density decrease, it makes the price increase. So now we move on the next part, literature reviews. I'll give you some information about the related theories. The first one is descriptive statistic. Is a brief descriptive coefficient that summarizes a given data set, which can be either a presentation or the entire sample populations. The next one is ordinary least square regression. It's a statistical method of analysis that estimates the relationship between the independent variable and the dependent variable. The dependent variable in this case is apartment price, and the independent in this case is square location and density. So now we're gonna move on the third part, which is presented by Minh Giang. So I will give her the spotlight now.
Now let's move to methodology. In this part, we will mention two research design and economic metric tests about research designs. After collecting data and decided what factor of effect to the price of apartment in Hanoi, we have the model is price equal to beta 1 hat plus beta 2 hat multiply area plus beta 3 hat multiply location plus beta 4 hat multiply density and error term. In order to decide how our model work effective or not, we do some economic metric tests or t-test, overall significance test, test for error term, additional variable in regression model. This is all about the methodology. Let's move to the next part is about the data analysis. In this part, we mentioned three factors is descriptive data, hypothesis testing, and testing errors. Let's move to the descriptive data. We have three graphs. So the key statistic of variable from three graphs we can know what mean, median, maximum, minimum, standard deviation, and probability of each variable. And the next graph is about the relationship between variable. In this graph, we can see the graph of the relationship between density and price, and relationship between area and price is no correlation. It means that when density and area change, it not affect to the price. And with the trend of negative, and about the negative trend of graph, show the relationship between location and price. We can see when the price increase, the location will decrease. It is all about the descriptive data. Now let's move to the hypothesis testing will be presented by Hami.
In hypothesis test, I will present the first one test is testing individual partial coefficient. In this test, we carry out the test for beta 2, beta 3, and beta 4. All the tests had the results that reject HO when T statistic is larger than the T critical value. Therefore, we conclude that the error, location, and density variable has an effect on the price of apartment in Hanoi. The second test is about testing the overall significance of O coefficient. Based on the data, based on the EView data, we state the null and alternative hypothesis. HO is beta 2 equals 0, beta 3 equals 0, and beta 4 equals 0. And H1 is at least one variable is significant. And we calculate the F statistic equal 13.33856 and find the F critical value equal 2.807 when level of significance is 0.05. As a result, we have decision rule is reject HO when the F statistic is larger than the F critical value. So there is enough evidence to conclude that at least one variable is different from 0. And the third test is the additional variable in the regression. In this step, HO is adding investment variable is not relevant, and H1 is adding investment variable is relevant. We find the F statistic equal 0.421 and the F critical value equal 4.0567 when the alpha equal 0.05. And based on the statistic, we can conclude that do not reject HO when the F stat is smaller than the F critical value. Therefore, investment variable is not significant for our model. And the last test is the functional form. We run the OLS regression and have the lean model, lean log model, log model, and log lean model. Based on with these models, we find the coefficient variance and adjusted R-square. As we know, the smaller coefficient variance and the higher adjusted R-square of the model, the more preferred equation. Therefore, the log lean form seems to be the best choice when it has the smallest coefficient variance and the highest adjusted R-square. And based on the log lean form, we have a better forecast and economic interpretation. Now we move the testing error will be presented by Hoàng Yến.
So now we continue with the last part, which is the testing for error. So we have three kind of errors, which are multicollinearity, the heteroscedasticity, and the last one is the autocorrelation. So move to the first error. To detect the multicollinearity, we have three ways to detect that. So first one, we run the auxiliary regressions and use the, otherwise we can use the correlation matrix in EView. And the last way is to use the variance inflation factor to decide the multicollinearities appear or not. So with the auxiliary regression, we have run three regression for each independent variable, which are the area, location, and building density. For area, we have, so we said for each independent variable, the hypothesis testing, which HO is there is multicollinearity in our model, and HA is there is no multicollinearity in our model. So for area, we have the F statistic is equal to 0.6453. With the F critical at 5% of level significant, we have the value of 3.23. Therefore, the F statistic is smaller than the F critical, then we do not reach HO. Therefore, there is not enough evidence to conclude that there is multicollinearity among independent variables. For location, we have the S statistic is equal to 0.7921, and the F critical at 5% level significant is 3.23. Therefore, the F statistic is smaller than the F critical, then we do not reach HO. Therefore, there is not enough evidence to conclude that there is a multicollinearity among independent variables. For building density, we have the F statistic, which is equal to 0.1469, and the F critical of 5% level significant is 3.23. Then with F statistic is smaller than F critical, we do not reach HO. Therefore, we can conclude that our model does not have the multicollinearity. And with the correlation matrix, here we will show you the result. We will show you the result of correlation matrix. As you can see that the correlation between these independent variables is too small, and moreover, the correlation between location and density is negative number. Therefore, we can conclude that the multicollinearity in our model does not exist in our model. So with the last way is the variance inflation factor. We can see that the center VIF, which is the center variance inflation factor, is smaller than 10. Therefore, we decide that the multicollinearity does not exist in our model. And move to the next arrow, which is the heteroscedasticity. In this arrow, we use the y-test to detect that. So with the y-test with the cross term, we can see that the LM is equal to observation multiplied by the R squared, which is equal to 3.407. And we can see that the LM is smaller than the chi-square, and then we do not reject HO. And we can conclude that there's not evidence to conclude the model has the heteroscedasticity. And the y-test with cross term, we can see that the LM is equal to 16.13022, which is smaller than the chi-square, and we do not reach HO. Therefore, we can conclude that the model does not have the heteroscedasticity. And the last error we need to detect is the autocorrelation. In this error, we use the Durbin-Watson's test, and we can see that our model satisfy the assumption, especially our model does not the heteroscedasticity, and the model has the error term with intercept. Therefore, we can conduct this test. We can see that the Durbin-Watson test statistic is equal to 1.662907. In the table of this statistic, we have the DL is equal to 1.21 and the DU is equal to 1.674. Therefore, we can see that the DW is greater than the DU. Therefore, we do not have any decision on this test. Therefore, we can conclude that our model does not have the positive autocorrelation. In conclusion, we can see that there is a significant relationship between the price of apartment and the three variables, which are area, location, and building density. Therefore, the larger area and the closer location along with the lower density, then the higher price of an apartment in Hanoi. And there is no errors occurring during the process when we running the review. Therefore, we can conclude this model is designed quite accurately and appropriately. And that is the end of our presentation. If you have any question, please message us through our email. So thanks for listening.